Hello everyone. In this part we will learn our second chapter, array as data structure. We know that array is a user defined data structure. In this chapter we will learn the different points. From this we will cover these points in our video. Editing of array, operations, array applications, searching. In searching we will learn sequential search, variations in a sequential search, sentence search, probability search, ordered list search. Let's see one by one. Array. Array is actually abstract data type. Why array is ADT? Because it holds a collection of elements accessible by an index. Actually, ADTs are a way of classifying data structure based on how they are used and behaviors they provide. The array ADT have one property. Okay, which is this property? They store and retrieve elements using an index. We are using the index number for storing and retrieving the element. The array ADT is usually implemented by an array data structure. Okay, we can perform the operations on array like a traversal of array, searching inside array. What are the applications of array? Mainly, we are using the array for the searching and sorting. These are the important applications of array. We are using the array in CPU scheduling algorithm, and in many applications we are using the array. But these are the two important applications of array. Searching. It is a technique of finding an element in a given list of elements. Here are the different methods for the searching. Sequential searching and binary searching. Sequential means here we can say it is a linear searching. Here we are searching the each and every element. Okay, one by one we are checking. In binary, in case of binary, we are dividing the whole array, and then we are start searching depending on the key and the condition. Okay, inside the sequential searching, there are the three types: sentinel search, probability search, and ordered list search. Sequential searching means what actually? Here we are examining all the elements starting from the first element. The process of searching terminates when the list is exhausted. Okay, or the list is end, or a comparison result in a success. Then we will stop. Okay, the sequential search is used whenever the list is not ordered. Okay, if the list is ordered, then we will use the binary search. We will also use this sequential search, sequential ordered search. Okay, the sequential search is used whenever the list is not ordered. Generally, you use this technique only for small lists or the lists that are the not searched often. Okay, see here is one example. Here is the array. Okay, in array the elements are 10, 5, 20, 45, 13 and 15. Okay, suppose a query search the element 20. Okay, let's try to search the element here. Okay, first compare this 20 with the first element. Okay, this 10 and 20 is not equal, so again search. Okay, again the second comparison is here. Okay, compare this 5 and 20. This 5 not equals to 20. Okay, then search with the next element. Okay, here is 20. 20 equals to 20. Okay, successfully we found this element 20 at the third location. So return the location third and the true, because this is found at in this array. Suppose we are using the next example. Search the element 16 inside this string. Okay, see, first element is 10, then 5, then 20, then 45. Compare with this first element. This 10 equals to 16? No. Then go to next one. Okay, search here. 10, 16 equals to 5? No. Then again go to the next step. Okay, then 20 equals to 16? No. Then go to the next. This 45 equals to 16? No. There is an end of array. So stop here, and this element is not found inside our array. So it will returns the false. Next is, let's see the C function for sequential search. When we are searching, then this is our array, this is our key, and this n is number of element inside the array. See, here is array, this is our key element, and number of element 1, 2, 3, 4. Okay, so n is your 4. While I less than n, okay, till the less than n, less than, not less than equals to less than n, if a of I equals to key, if you found the element a of I, if you found the element this key inside your array, then return I, means the return the index number, return the location. If not, then increment the I, then check again for this till the end of array or the successful operation. Otherwise return -1. This is our first type of the sequential search, centile search. What is mean by centile search? Here we are adding the one element at the end of array. This element is our centile value. Algorithm A, either the target is found or last element is compared. Okay, the algorithm can be modified to eliminate the end of list. Centile search. Centile search means what? Here we are adding the one extra value at the end of array. This additional entry at the end of this list is called as a sentinel. Okay, which value we are adding? We are adding the key element. Okay, sentinel value is the one whose presence guarantees the termination of a loop that processes structured or sequential data. Okay, so let's see. Here is a pseudocode for this algorithm. Sentinel search. Here we are providing the list or last and then target and this location. Okay, list. List contain at least one element. Last is index to the last element in the list. Target is contains the data to be located and location is address of an index in calling algorithm. See here, set list of last plus 1 to target. Okay, target means what? Contains the data to be located. We are assigning this target to the list of last plus 1, means we are adding the one value at the end of our array, end of our list. Then set looker to I. We are setting the one value to the 0. Then loop target not equals to list of looker. Okay, till which we are finding, okay, target not equals to list of looker. Okay, till the end, till the key we are finding, increment the looker. Okay, till this increment the looker till the target, then end loop. If looker less than equals to the last, then set found to true. If found, then set found to true and set location to looker. Else set found to false and set location to last element. Then end if. End if. Here is a end if. And then see, here is our if is starting from here. One if is from this to this. Okay, and one if is from the starting. So end if, then return found. Okay, then after this return found and then end probability search. Here is a code for this boolean. Okay, it will returns you either true or either false. So sentinel search, here is your key int I. You can assign this key to the roll number. Okay, key to the roll number of n. If for I equals to 0, roll number of I not equals to key, till this key we are finding and incrementing the counter. Okay, if I less than n, then it returns true, otherwise returns the false.